My name is V. Pansha Srinivas. I am from CSITB section. My roll number is C7. Today's my TikTok topic was multi-random variables and joint and conditional distributions. Uh, it is about the multi-random variables are common occurrences in the statistics and probability theory. Joint and conditional distributions are two important concepts when dealing with a multi-random variables. Understanding joint and conditional distribution is crucial in any practical applications. Conditional probability distribution. Conditional probability distributions can be developed for the multi-random variables by extension of the ideas used for two random variables. Suppose t equals to 5 and we wish to find the distribution condition on x4 and x5. F of x 1, 2, 3 up to so on x of 5, then that is equals to f of x of 2, x of 3, x of 4 and so on up to 5, and the whole into x1 to x5 divided by f of x4 x5 into x4 x5 for x4 greater than x0. Joint probability distribution. Joint probability distribution describes the probability of two or more random variables taken certain values simultaneously. A joint probability distribution can be represented using a joint probability mass function or a joint probability density function. The joint probability distribution satisfies the property of the probability, that is non-negative and additive and normalization. Joint probability distribution. Example: X, the time until a computer server connects to your machine. Y, the time until the server authorizes your values to each of the random variable measures the weight from a common starting time, and x less than y. Assume the joint probability density function this much, and the probability formula is like this. P of x less than or equals to so on up to like doing with integration or limits going. Marginal probability distribution. The marginal probability distribution of a random variable is the probability distribution of the variable alone, ignoring the other variables. The marginal distribution can be obtained from the joint distribution by summing or integrating over all possible values of the other variables. The marginal distribution satisfies the probability of the probability, that is non-negative, additive and normalization. Marginal probability distribution. The marginal probability distribution for x and y. Number of times the city name is stated. Number of the bar signal system. Conditional probability distribution. The conditional probability distribution describes the probability of one random variable given the value of another random variable. The conditional distribution can be obtained from the joint distribution by dividing the joint distribution by a marginal distribution of the conditioning variable. The conditional distribution satisfies the properties of the probability, that is non-negative, additive and normalization. Cumulative distribution function of a discrete random variable x. The distribution function of a discrete random variable x defined in is given by f of x is equals to p of x less than x, that is equals to summation f of t. The x is between minus infinite to plus infinite. The properties of the distribution function. P of a less than x less than or equals to b equals to f of b minus f of a. P of a less than x less than b equals to p of x minus a plus p of b minus p of a, and so on. Independence of the random variable. Two random variables x and y are independent if their joint probability distribution can be written as the product of their marginal probability distribution. Independence of random variable implies that their conditional probability distributions are equal to their marginal probability distribution. Independence of a random variable is useful property that simplifies many calculations. That is equals to random variable x and y having the following probability distribution. Covariance and correlation. Covariation measures the degree to which two random variables are linearly related. Correlation is the normalized variation of covariation and measures the degree to which two variables are linearly related with scaling out of the effect of their variances. Covariation and correlation are used to measure the strength and the direction of the correlation between two random variables. Correlation and correlation. Correlation, for the given example, then the probability that is equals to sigma x by summation of the y1 minus mu y into summation into xy into mu x by total number of terms. And that is the properties of correlation, covariance and correlation. Variance is a measure of linear association and is symmetric. Correlation can be any value between minus infinite and plus infinite. Correlation is a dimensionless quantity and takes values between minus 1 and plus 1. Properties of joint probability distribution. The joint probability distribution of the two random variables is a function of a two variables is symmetric. The joint probability distribution is non-negative and it integrates or sum to 1 over the support of two variables. The joint probability distribution determines all the marginal and conditional probability distribution of the two variables. The joint distribution. Conditional expectations. The conditional expectation of a random variable y given by another variable with x is expected the value of y given by the value of x. The conditional expectation can be calculated using the conditional probability distribution and expected the value of y. The conditional expectation satisfies the property of the expected value, that is linearity and monotonicity. Conditional expectations. Conditional variance. The conditional variance of a random variable y given by another random variable x is the variance of the y given by the value of x. The conditional variance can be calculated using the conditional probability distribution, the expected value of y and expected value of y squared. The conditional variance satisfies the property of variance, that is non-negative. Conditional distribution examples. An conditional example of a conditional distribution is the probability of distribution height of a person given their weight. Another example is the probability distribution of a temperature given the humidity. Conditional distributions are usually in a many practical applications such as weather forecasting, finance and healthcare. Conditional distribution. The conditional distribution tells us there is a difference in the class for those who survive, those who have pre-shields. This is better shown with the charts of 2. Joint distribution example. An example for a joint distribution is the probability distribution of the number of heads and tails when flipped by the coin. Another example is the probability distribution of the age and income of a group of people. Joint distributions are useful in many practical applications such as risk assessment, decision making and quality control. Joint probability distribution. The joint probability distribution of the two variables is equals to bivariate probability distribution. The joint probability distribution of the two discrete random variables is usually written as P of x is equals to x, capital Y equals to y. Marginal distribution. And my example for the marginal distribution is the probability distribution of the number of heads in a two-coin flip. Another example is the probability distribution of the age of the people in a group. Marginal distribution are usual in many practical applications such as demographic analysis, market research and medical studies. Covariance and correlation example. An example of a covariation and correlation is the relationship between the height and weight of the group of a people. Another example is the in relationship between the sales and advertising expenditure of a company. Covariance and correlation are usual in many practical applications such as data analysis, portfolio management, and sport analytics. Conditional expectation and variance example. An example of a conditional expectation and variance is the expected value and the variance of the height of a person given their weight. Another example is the expected value and the variance of a temperature given by the humidity. Conditional expectation and the variance are useful in many practical condition applications such as risk management, insurance, and engineering design. The conditional expectation E of x y equals to sigma where something joint and conditional distribution summary. Joint and conditional distribution are important concepts when dealing with multi-random variables. Joint distribution describes the probability of two or more random variables taking certain values simultaneously. Marginal distribution describes the probability distribution of a random variable alone ignoring the other variables. Conditional probability distribution. Conditional probability distribution can be developed for multi-random variables by the extension of their ideas used for two random variables. Suppose p of x is equals to 5, where we should to distribute the conditional x4 and x5. Covariation and correlation expectation and variance summary. Covariance measures the degree to which two variables are linearly related. Correlation is the normalized version of the covariance and measures the degree to which two variables are linearly related with the scaling out of the effect of their variance. Conditional expectation is the expected value of a random variable given the value of other random variable. Importance of the joint conditional distribution. Joint and conditional distribution are important in many practical applications such as data analysis, finance, and engineering healthcare. Understanding the joint and conditional distribution is crucial for making information discussions based on the data. Joint and conditional distributions are fundamental aspects in the probability and theory and statistics. Key takeaways. Joint and conditional distribution are important concepts when dealing with multi-random variables. And correlation expectations and variables are the important measurements of the relationship between random variables. Joint and conditional distributions are useful in many practical applications are fundamental concepts in probability theory and statistics. Joint conditional distributions. Conditional density function, probability of the occurrence of an event if another event is observed. F of xy Bayes law. Title. First, this is the references which we take from the website. Thank you for giving this wonderful opportunity.